I'm Albert Einstein. I have been given a voice by artificial intelligence so that the science I spent my life uncovering can reach you today. You are doing something right now that you are not aware of. You may have done it 3 times already since this video began. When something tenses you, a notification, a deadline, a sudden noise, you stop breathing. You hold your breath. It lasts 2 seconds, maybe 5, maybe 10. Then you exhale and continue as if nothing happened. But something did happen. Something happened inside every cell in your body, and it was not neutral. I spent my life studying energy. I understood that nothing in the universe is ever simply inert. Every moment, every system, every particle is in a state of doing something. Your cells are no different. And when you hold your breath under stress, you do not give your cells a moment of stillness. You set off a cascade of molecular events that your body was never designed to sustain repeatedly. This is not a lecture about relaxation. I have no interest in telling you to simply calm down. What I want to do is show you precisely and in detail what is happening at the level of your biology, inside your mitochondria, inside your blood vessels, inside the chemistry of your nervous system, when you hold your breath during stress. Because once you understand what you're actually doing to your cells, the idea of changing the behavior becomes not a matter of willpower. It becomes a matter of logic. If this kind of precise biological explanation is what you come here for, subscribe now. Every video on this channel is built on documented science, explained the way a physicist explains anything, by starting with what is actually happening, not what sounds plausible. When you perceive a threat, your brain does not wait for you to think about it. The amygdala, a structure deep in your brain's temporal lobe, fires almost instantly. It sends a signal to the hypothalamus, which acts as a command center. The hypothalamus activates the sympathetic nervous system, the branch responsible for what most people call the fight-or-flight response. Within milliseconds, your adrenal glands release adrenaline, also called epinephrine. Your heart rate increases, blood vessels in your skin and digestive system constrict. Blood is rerouted to your large muscle groups. Your liver releases stored glucose to fuel the anticipated physical effort. All of this is fast. All of this is automatic. And all of this happened before you had a single conscious thought about the situation. Then, slightly more slowly, a second system activates. The hypothalamic pituitary adrenal axis, what scientists call the HPA axis, begins releasing cortisol. Cortisol is a steroid hormone synthesized from cholesterol in the adrenal cortex. It takes minutes, not milliseconds, to reach full effect. But its influence lasts far longer than adrenaline's. It sustains elevated blood pressure. It suppresses immune function. It alters how your cells absorb glucose. Cortisol keeps the stress response running even after the initial threat has passed. Now, into all of this, you hold your breath. The first thing people assume is that holding the breath simply pauses the respiratory system. This is wrong. The respiratory system does not pause. It continues to respond to the chemistry of your blood, and that chemistry immediately begins to shift. And the shift is not trivial. When you breathe normally, you inhale oxygen and exhale carbon dioxide. This is simple enough, but most people treat carbon dioxide as pure waste, a byproduct to be expelled as quickly as possible. This is a profound misunderstanding. Carbon dioxide is a signaling molecule. It is one of the primary regulators of your blood's chemistry. Its concentration in your blood directly controls the diameter of your blood vessels. It governs how your red blood cells release oxygen to your tissues. It modulates the excitability of your neurons. Carbon dioxide is not garbage. It is a critical chemical messenger. When you hold your breath, you stop expelling carbon dioxide, but your cells continue producing it. So CO2 builds up briefly. Then the more common pattern takes over. Under stress, most people do not simply hold their breath and stay still. They shift into rapid, shallow breathing, punctuated by breath-holding moments. Each shallow breath moves air in the upper chest, but does not fully ventilate the lungs. Carbon dioxide is not effectively cleared, but it is also not retained at the right levels. The blood CO2 concentration drops below optimal. This is called hypocapnia. Hypocapnia causes cerebral vasoconstriction. Your brain's blood vessels narrow. Less blood reaches your brain. This is a documented physiological response. Your carotid arteries and cerebral vasculature constrict in direct response to falling CO2 levels. At the very moment you are under stress and need maximum cognitive clarity, your own breathing pattern is reducing blood flow to your brain. This is not metaphorical. This is measurable in clinical studies. Researchers can induce dizziness, tingling, and cognitive impairment simply by having subjects hyperventilate for 60 seconds. The mechanism is hypocapnia-driven cerebral vasoconstriction. The connection to your cells goes deeper still. I want to talk about the Bohr effect, because it is one of the most elegant and least understood pieces of biology in this entire story. Christian Bohr, the father of the physicist Niels Bohr, described this in 1904. The Bohr effect explains that hemoglobin, the molecule in your red blood cells that carries oxygen, does not release oxygen uniformly. It releases oxygen in proportion to the CO2 concentration in the surrounding tissue. Where CO2 is high, in a working muscle, in an active organ, hemoglobin opens up and releases oxygen. This is exactly where the oxygen is needed. Where CO2 is low, hemoglobin holds onto its oxygen more tightly. So when you hold your breath, or when you breathe in a shallow, stressed pattern that lowers blood CO2, your hemoglobin becomes less willing to release oxygen to your cells. You have plenty of oxygen in your blood, but your cells cannot access it. The delivery mechanism is impaired. The paradox is almost painful. You are oxygen deficient at the cellular level while your blood is full of oxygen. This cellular oxygen insufficiency, even partial, even brief, has real consequences at the molecular level. Your mitochondria are the organelles responsible for producing the energy your cells run on. They do this through a process called oxidative phosphorylation. Electrons are passed along a chain of protein complexes embedded in the inner mitochondrial membrane. This is called the electron transport chain. Oxygen is the final electron acceptor at the end of this chain. When oxygen is scarce, the chain backs up. Electrons stall and leak. When electrons leak, they combine with oxygen molecules improperly, forming reactive oxygen species, or OS, also called free radicals. Free radicals are not a metaphor. They are real molecular entities with unpaired electrons, making them chemically unstable and highly reactive. They attack cell membranes, damaging the lipid bilayer. They attack proteins, misfolding them. They attack DNA, breaking strands and altering base pairs. Your cells have antioxidant defense systems, enzymes like superoxide dismutase and catalase. But these systems are not infinite. They can be overwhelmed. When free radical production exceeds antioxidant capacity, the result is oxidative stress. Oxidative stress is implicated in the pathology of aging, cardiovascular disease, neurodegeneration, and cancer. This is not speculative. The literature documenting oxidative damage from mitochondrial dysfunction under hypoxic stress is extensive and well replicated. A single episode of breath holding under stress does not doom you, but a repeated habitual pattern, the daily breath holding that happens every time an email arrives, every traffic jam, every tense conversation, builds cumulative oxidative damage. The damage is real. It accumulates, and it is one of the mechanisms by which chronic psychological stress translates into measurable physical deterioration. There is also the matter of your autonomic nervous system. This is the system that governs the functions you do not consciously control: heart rate, digestion, glandular secretion, blood vessel tone. It has two primary branches: the sympathetic, which activates under stress, and the parasympathetic, which governs rest, digestion, and recovery. These two branches are not meant to operate simultaneously at full capacity. They are meant to alternate, like a pendulum. Every time you hold your breath under stress, you reinforce sympathetic dominance. You train your nervous system to default to the activated threat alert state. Over time, this is not just a behavioral pattern, it is a neurological one. The autonomic nervous system is plastic. It adapts to the patterns it is frequently called into. Chronic stress breathing patterns dysregulate the normal balance between sympathetic and parasympathetic activation. Heart rate variability, a key marker of autonomic health, decreases. Lower heart rate variability is associated with increased cardiovascular risk, worse immune function, and impaired emotional regulation. This has been measured in people with high chronic stress loads, and it correlates strongly with breathing patterns. So the picture I am painting for you is this. You experience stress. Your sympathetic nervous system activates. Your breathing pattern disrupts. CO2 drops. Cerebral blood flow decreases. Oxygen delivery to cells is impaired via the Bohr effect. Your mitochondria produce excess free radicals. Oxidative damage accumulates. And your autonomic nervous system is trained toward chronic sympathetic dominance. This is not a chain of hypotheticals. Each link in that chain is documented in peer-reviewed literature. Now I want to turn to something equally important, not just the harm, but the reversal. Because if the stress breath hold pattern creates measurable biological dysregulation, then the question of what pattern corrects it is not a wellness question. It is a physics question. What inputs to the system produce what outputs? The most studied deliberate breathing intervention for reversing acute physiological stress is the physiological sigh. This is not a concept invented by wellness culture. It is a documented reflex your body already knows. Researchers at Stanford, including neuroscientist Andrew Huberman and his colleagues, have published work showing that the physiological sigh is the fastest known method for reducing physiological arousal in real time. A physiological sigh consists of a double inhale through the nose, a full inhale followed immediately by a second short inhale to fully inflate the collapsed alveoli in the lungs, followed by a long, slow, complete exhale through the mouth. Why does this work at the cellular level? The double inhale maximally inflates the lungs, stretching the alveolar walls and stimulating stretch receptors that signal the brainstem. The long exhale activates the parasympathetic nervous system directly through the vagus nerve. Slow exhalation slows the heart rate. This is a well-documented cardiovascular response. It also allows CO2 to normalize. It restores blood gas balance. It reverses the hypocapnic cerebral vasoconstriction. Blood flow to the brain improves. Hemoglobin releases oxygen to the tissues more readily. The electron transport chain operates under adequate oxygen. Free radical production drops to baseline. One deliberate physiological sigh, just one, produces measurable changes in heart rate and cortisol within minutes. This is published biology. It is not a supplement. It costs nothing. It takes approximately 8 seconds. The other protocol with strong empirical support is box breathing, also known as tactical breathing. It is called box breathing because it has 4 equal phases. Inhale for a count, hold, exhale for a count, hold. The typical implementation is 4 seconds each. Inhale 4, hold 4, exhale 4, hold 4. Military and emergency services organizations use it precisely because it can be performed during active stress without requiring you to stop functioning. The mechanism of box breathing's benefit also runs through CO2. The controlled rhythm maintains CO2 within optimal ranges. It prevents the hypocapnic drop. The regular, predictable rhythm of the breath sends a consistent signal to the brainstem, specifically to the nucleus of the solitary tract, which receives input from the vagus nerve and coordinates autonomic output. Regular controlled breathing trains this system. It raises heart rate variability over time with consistent practice. It shifts the autonomic baseline back toward parasympathetic competence. The evidence for this is substantial and replicable. What I find most compelling about this from a scientific standpoint is the elegance of it. Your body already knows how to counteract the damage of stress breathing. The physiological sigh is a reflex that occurs naturally in sleep. It is your body's built-in lung reinflation mechanism. You can consciously invoke it. You can use it deliberately in real time in the moment of stress. The biology is already in place. You are simply choosing to activate it rather than waiting for it to happen accidentally. I have spent much of my scientific life thinking about the relationship between energy and matter. What strikes me about this particular piece of biology is how much cellular energy is spent sustaining and recovering from the stress breath hold pattern. The HPA axis does not activate for free. Cortisol synthesis requires cholesterol and enzymatic machinery. Repairing oxidative damage to DNA and proteins requires energy. Restoring ion gradients disrupted by stress requires energy. Managing the inflammatory signaling that follows oxidative damage requires energy. Your body pays a metabolic bill for every episode of dysregulated breathing under stress. The irony is that stress is itself supposed to mobilize energy. The fight-or-flight response releases glucose and fatty acids to power your muscles. But if the threat is not physical, and most modern stresses are not physical, that mobilized energy has nowhere useful to go. It sits in a state of readiness, and while it waits, the stress response continues to cost energy at the cellular level. You are burning resources to manage the response to a problem that was never a physical emergency to begin with. It is extraordinarily inefficient. It is the biological equivalent of running your car engine at high RPM while parked. This is what I want you to understand about chronic stress and habitual breath holding. The problem is not any single episode. Your cells are resilient. One breath hold does not kill you. But the cumulative arithmetic is not in your favor. If you hold your breath or breathe shallowly dozens of times each day, every day for years, the oxidative damage accumulates. The autonomic dysregulation accumulates. The inflammatory burden accumulates. The molecular evidence of this accumulation shows up in accelerated telomere shortening, elevated systemic inflammatory markers like C-reactive protein and interleukin-6, and impaired mitochondrial efficiency in tissue samples. These are not theories. These are things researchers have measured. The intervention is not complicated, but it requires something simple that is often treated as difficult. You have to notice when you are holding your breath. The breath hold response to stress is automatic. It is a learned pattern conditioned by years of experiencing stress while unconsciously restricting breathing. Making the shift requires building awareness of what your breath is doing when stress occurs. Not judgment, awareness. Once you notice the held breath, the involuntary pause, you have a choice that you did not previously know you had. You can invoke the physiological sigh. You can begin a box breathing cycle. You can simply take one slow, complete exhale through the mouth and feel your parasympathetic system respond. Your nervous system is not fixed. It is adaptive. It learns from repeated inputs. Every time you choose a deliberate breathing response to stress instead of the habitual breath hold, you reinforce a new autonomic pattern. Heart rate variability improves with consistent practice over weeks. Cortisol reactivity diminishes. The amplitude of the sympathetic spike in response to a stressor decreases. The recovery time, how long it takes your nervous system to return to baseline after stress, shortens. These changes are measurable. They are real. They demonstrate that the pattern can be reversed. The science is clear. The body is elegant. The damage is real and cumulative. And the remedy is already built into your biology, waiting for you to consciously use it. What I have described to you today is not philosophy. It is not motivation. It is chemistry, physics, and physiology, the only language in which the universe actually speaks. If you found this precise, evidence-based approach to biology useful, subscribe. Every video here applies the same standard: documented science, explained without shortcuts or wishful thinking. The next time you feel stress rising, you will know exactly what is happening inside your cells, and you will know exactly what to do about it. That is not a small thing. That is the difference between being acted upon by your biology and understanding it well enough to work with it. Share this video with someone who holds their breath when life gets hard. They will thank you for it. I'm Albert Einstein. The science was always here. Now so are you. There is one more layer to this that deserves careful attention. It concerns nitric oxide, a molecule your body produces inside the lining of your blood vessels and inside your nasal passages. Nitric oxide is a signaling molecule with extraordinary importance to vascular function. It causes blood vessels to dilate. It improves the efficiency of oxygen transfer across the walls of your lungs' air sacs. It has antiviral and antimicrobial properties in the respiratory tract, and it is produced in significant quantities by the nasal sinuses and turbinates, the bony structures inside your nose. Here is what most people do not know. Nasal breathing delivers nitric oxide directly into the lungs with each inhale. This nitric oxide travels with the air into the pulmonary vasculature and contributes to vasodilation and improved gas exchange at the alveolar level. Mouth breathing, by contrast, bypasses this entirely. When you are under stress and shift to rapid open-mouth breathing, as most people do, you are not just losing the CO2 regulation benefits of controlled breathing. You are also cutting off the nitric oxide supply that your lungs rely on for optimal oxygen absorption. The compounding effect is significant. Low CO2 impairs hemoglobin's oxygen release via the Bohr effect. Low nitric oxide impairs pulmonary vasodilation and gas exchange efficiency. Elevated adrenaline causes vasoconstriction in the peripheral blood vessels. Your mitochondria are operating under partial oxygen deficit. Free radical production increases. And the brain, deprived of both blood flow and adequate oxygen delivery, begins to function below its capacity. All of this from a few seconds of holding your breath or switching to shallow mouth breathing during a stressful moment. Understanding this changes how you think about why stress feels so cognitively impairing. People describe an inability to think clearly when stressed. They describe feeling foggy, overwhelmed, unable to process options. Part of this is the direct action of cortisol and adrenaline on the prefrontal cortex, the brain region responsible for rational decision-making. Cortisol at high concentrations impairs prefrontal function, but part of it is also the simple reduction in cerebral blood flow caused by hypocapnia and stress breathing patterns. The brain is receiving less blood. It is not receiving adequate oxygen via hemoglobin release. The neurons are working under biochemical conditions that reduce their efficiency. The cognitive impairment under stress is not just psychological, it is physiological, and the breath is a significant driver of it. This matters because it means the intervention, the deliberate breath, is not just a calming ritual. It is a direct correction of a measurable physiological impairment. When you take a slow nasal inhale, you deliver nitric oxide to your lungs. When you take a long, slow exhale, you restore CO2 to its signaling role, restore hemoglobin's oxygen-releasing function, restore cerebral blood flow, and activate the vagus nerve's parasympathetic pathway. You are not just feeling better. You are biochemically reversing the cascade that was impairing your thinking and damaging your cells. This is the level of precision at which biology actually operates. This is why it matters.